Hello and welcome everyone. My name is Peter Robinson and today we've got Rafael who is going to tell us about blockchain interoperability. But Rafael, before you share your slides, please introduce yourself.
Hey Peter, hello everyone. I actually have a slide for that, a very quick one. Yeah, I'm a PhD student in Lisbon, Técnico Lisboa, and I'm exploring the vast depths of blockchain interoperability. And today I'm trying to sum up our findings about interoperability, trying to provide general landscape for you to know what's happening.
Thank you. Well, please share your slides.
Right. All right, that should be it. So
yep,
the title of the talk is The State of Blockchain Interoperability in 2021, because it is based on a survey we conducted. So me, Miguel Correia, André Vasconcelos, my PhD advisors, and also Sérgio Correia from our group. And this survey was done in 2020, but it was updated as of 2021. So I'm a PhD student, as I referred. I've been involved with the Hyperledger Foundation, proposing some projects for their Hyperledger Summer Internship project or initiative. And I'm currently participating in Hyperledger Cactus, dedicated to interoperability, and also the Internet Engineering Task Force, designing ODAT, which is the Open Digital Asset Protocol. I'll talk a bit about those projects later. Regarding the outline, I'm going to talk a bit about interoperability. What does that mean? Why is it important? Then, and this QR code, by the way, it's a link to the survey we conducted, I hope. And after that, I'll explain what are the solution categories that we derived from the current landscape. I'll provide some directions, in particular, some examples, in particular Cactus, and then provide some future research directions and conclude. So why does interoperability matter? First of all, there is a set of requirements we need to fulfill in order to have a useful blockchain use case, right? So one of them is if we need more than one entity to contribute data, if we need to take into account the position, the perspective of several parties, right? If we don't, then the authors of this scheme propose that we just use a normal database, and we can keep going. We also need to consider, for example, if records need to be deleted, right? In a typical blockchain, you don't have the possibility to delete records, only to append to the ledger. And you have a sequence of conditions that you need to fulfill in order for you to have a useful blockchain use case. But this is actually a bit outdated, and we know that recently there has been a huge improvement on several distributed ledger technologies. Some of them are focusing on aspects about identity, others are focusing on scalability, like Ethereum 2.0, and others focusing on permission enterprise use cases. This leads to not only data and value silos, but also to fragmentation. We'll end up in a situation where we have several isolated blockchains that cannot really talk to each other and that solve their specific problem, right? And this is a problem because it limits our ability to, to explore synergies and to generalize across industries. Furthermore, it requires a huge investment for a company to develop their blockchain solution. And as it requires a huge investment, and actually the return on investment is it's very high, takes quite a long time. Enterprises are actually reluctant of investing, right? Because they're limited in communicating across chains, right? So one of the solutions for this problem is also blockchain migrations. So you take a blockchain that is potentially obsolete or does not satisfy your use case anymore, and you can migrate that blockchain to another. This is a use case or possibilitated by interoperability. Yeah, so actually this information is a bit outdated. So the market cap at the time was 260 billion. I checked yesterday, coin market cap, I think that's the website, and it said 2 trillion. Well, we've seen a huge rush on cryptocurrencies in particular in these last months. So it doesn't come with a lot of surprise that the market cap of the cryptocurrency space has skyrocketed. But in any case, we have a huge interest spread across hundreds of blockchains, right? But unfortunately, we always have this risk of a blockchain to be rendered obsolete, and thus we need to change it, or at least we need to communicate with the outer world. And here you have two examples. One of them, the DAO attack, which emphasized how fragile or the lack of security tools that exists regarding smart contracts. So we need to invest in protecting against those attacks. In the extreme, this could lead someone to abandon their blockchain project. And in the other end, we have the case of Hyperledger Composer, which was a quite popular tool to facilitate the development of Hyperledger Fabric contracts, but it was discontinued. So lots of people had to manually migrate their solutions. And besides that, to conclude the introduction, also the integration is a difficult problem, right? If we're connecting every ledger between themselves, we have combinations. So if we want to connect 10 ledgers to each other, we would have 45 integration scenarios, right? And this scales very quickly. Of course, that if you want to connect a centralized system or, excuse me, or even a decentralized system to each ledger, then you don't need as many integrations because you don't need to connect them between themselves. But it is still a lot of work that it's currently not very well standardized. Well, you have the Rosetta API and a few more, but they have their own limitations. For example, they're not directed to private blockchains. Some people say that we are again on the peak of inflated expectations. I like to think that we're already on the slope of enlightenment, where we're really starting to think what is the value behind blockchain value, and already exploring standardization, interoperability, enterprise and governmental use cases, and that give us some hope for stability in the space. And my position is that interoperability will play a huge role for us to move from the slope of enlightenment to the plateau of productivity. Our study was conducted from December 2019 to up to March this year. We analyzed lots of documents and we came up with the analysis of around 70 papers well, we tried to make it in a systematic way. The first key finding was that the research trends on interoperability are skyrocketing from year to year. And this was actually taken from Google Scholar, the number of matches. And we can see a clear increased tendency over the years. Other finding was that there is already some attempts at systematizing blockchain interoperability. Okay, there are some very good surveys which inspired and had driven this work. For example, Butterins in 2016, way ahead of its time. Johnson's, Zamyatin's, Bishnoi's. And these works are trying also to do something similar to our work, which is to systemize certain category of solutions. Okay. Where you see PC on the solution category, that stands for public connectors. So the solutions that connect public blockchains essentially, and we can see that most of the work has been directed to this type of solutions and not so much to the blockchain of blockchains, which I'll explain later, and also to hybrid connectors, which connect public to private blockchains and other centralized systems, decentralized systems. So our survey tries to take a look in each of the directions and come up with a cross analysis between the categories. But I still recommend you to take a look at each of the surveys if you want more specific information about a certain topic. Okay, we give the general overview. Of course, we cannot be as detailed as other surveys on, for example, public connectors, because the others are focusing explicitly on that. We also tried to collect and to process and to show information about architectures for blockchain interoperabilities. That's AR, for standards on interoperability, ST, across analysis between solution categories, use cases, and research directions at the end, OI. This is one of the main contributions of the paper. This is a table. On the left side, you have the subcategories of blockchain interoperability solutions, right? So the first three in green are public connectors, and they aim to connect to connect public blockchains to each other. This categorization is based on Butterins categorization, and most of the work done so far is here. Okay, and one could argue that interoperability between public blockchains, it's more or less solved. There's still a long way to go regarding efficiency and security, but people are more or less agreeing on how to do it, and this is very good because it provides us a very solid basis for the next steps. Next, we have the blockchain of blockchains solutions. This includes Polkadot and Cosmos. Essentially, blockchain of blockchains are solutions that expose a framework for you to develop your own blockchain-specific applications. Okay, and those instances of those platforms can interoperate between each other. Okay, we differentiate this category from relays and sidechains, and I'll give some details on this a bit later. And finally, we have hybrid connectors, which connect public and private blockchains. And here we have trusted relays, blockchain agnostic protocols, and blockchain migrators. Trusted relays are, let's say, centralized trusted parties that, or semi-centralized trusted parties that you can leverage for conducting interoperability processes. So, for example, I have my Hyperledger Cactus node, and it has some business logic running, and it can understand, okay, if something happens on Ethereum, then I need to issue transactions against Fabric. Okay, blockchain agnostic protocols provide a blockchain abstraction layer, mostly, or in many cases, this layer is not backward compatible with what exists. So existing blockchains need to be adapted to use it. Or they're the solutions, or not or, and the solutions that are blockchain agnostic protocols can simply provide a blockchain abstraction layer that, for example, a standardized data model that allows blockchains to communicate. And finally, a special case, blockchain migrators allow migrating between blockchain platforms. Okay. Yeah, this is on the left part. You have the references on the right part, and then you have the criteria by which classification was driven. You have the details on the paper. I'm just giving a general overview. And those are divided into the asset that wants to be migrated and the trust establishment methods. So the asset types, people like to distinguish it between data and tokens. Because data can be freely moved around blockchains, while tokens, you would want to guarantee that double spend is respected on both chains. So that's a bit more complicated problem to solve. So essentially, this criteria, D data, says which solutions can move around data. And P stands for payment tokens, and U for utility tokens. So fungible and non-fungible tokens. Infrastructure stands for, it's the infra, P public blockchains, and P non-public blockchains. So private blockchains, centralized systems. We can see that most solutions are directed to public blockchains, public infrastructures. Decentralization is how decentralized the solution is, if it's at the user level, at the consortium level, or if it's a trusted third party. The channel is where the cross-chain transactions are settled, initiated, processed, settled. Can be in an on-chain channel using a smart contract, for instance, or in an off-chain channel, for example, using payment networks, payment channels, although payment channels use a mix of both. So essentially you generate proofs and use those proofs to perform off-chain computation that then is pegged to the main chain. And finally, we have cross-chain realization. So how are effectively cross-chain transactions realized, implemented? We have escrowed cross-claims, and I've taken this term inspired by the cross-claim paper. And the escrowed cross-claims are, so envision it in a very simple way. Like in one blockchain, you are burning or destroying or locking a token, and in the other blockchain, you are unlocking or minting, creating a token. That's generally cross-claim, and it's escrowed because that process is conducted by a smart contract, for example. While cross-claims are the same process, but without those mechanisms, okay? So we're not trusting a smart contract to enforce that. We're trusting a third party that can be regulated, that can be accountable to the law, to regulate those cross-chain transactions. Okay? And this is the gateway-based paradigm that Thomas Arjono from MIT and his colleagues have proposed. And finally, M, mediated by a third party, typically exchanges, notary schemes. So it's a lot of information, definitely. The first solution, subcategory solution, it's sidechains and relays. Okay, Peter will talk a bit about those, I believe, in the next upcoming weeks. But very generally, a sidechain is, or a secondary chain, is an extension to the original blockchain, where you can offload processing. You can have another set of features, and the sidechain is pegged to the main chain. Okay? An example of it is the Bitcoin relay, which is an Ethereum smart contract that receives blockchain block headers, right? And this allows it to prove transaction inclusions on the Bitcoin network, right? And this is very useful if you want to conditionally issue transactions on the Ethereum network based on what happened in the Bitcoin network, right? It can allow you to define use cases such as if you send X Bitcoin to this address, then something will happen on the Ethereum network. This is quite, I think this is quite used. There's a paper from Philip, Martin, and their colleagues called Testimonium, which is an efficient relay that performs sort of what the Bitcoin relay does, but in a bit more efficient way. It's very interesting. Right, I'll save you the details. Some of the sidechain solutions are depicted here in a high level. This is actually in the appendix of the paper, not in the main paper anymore. Then we have notary schemes. Okay, you as the end user use an exchange to buy cryptocurrency. Okay, that's the typical use case. Of course, there are some catches, right? In some exchanges, you actually don't own the keys, the private keys to these cryptocurrencies. So you are only buying the representation of such assets or the promise that you'll get such assets. So you have to trust these services a lot, right? I've put Visa there. Visa is a payment network because they're also entering the game by allowing, and this is actually quite recent, by allowing people, I think that's their vision, to pay with cryptocurrencies using their payment network. And we also have decentralized exchanges. Essentially, they are a public bulletin that post and advertise offers for trading different assets. And finally, we have the HTLCs, hash time lock contracts. These are, let's say, one of the standard mechanisms to perform cross-chain asset transfers. Okay, I'll save you the technical details here, but essentially, you have two parties. One of them generates a secret, right? And it publishes a smart contract into one of the blockchains saying that if it receives such secret, and that is encoded in the hash as the hash of the secret, right? Then if it receives it, it will send the assets to Bob, to the other party. Correspondingly, Bob, the other party, when he sees this transaction posted, he sees the hash that is in the smart contract. So he uses this hash to publish his own smart contract saying, okay, if I receive the secret S, such as the hash is this, then I'll send my assets to Alice, right? And what happens is that Alice sends the secret to Bob. Bob has the secret, and now he can use it on Alice's smart contract. So assets
Rafael, I think your audio has just dropped out.
Sorry.
Rafael, can you hear us? Can anyone hear me?
Yeah, we can. Yes, sorry, I thought it was me, the other Rafael. Yeah, I can't hear Rafael anymore. No more.
Okay. Oh, he's dropped off the call. So not to worry, everyone. I'm sure. Oh, you're back. Good. Can you hear us? Oh, no. No, I think your Bluetooth headphones are not working. Can you hear us? Yeah, I can't hear you yet. So for those who can't see the chat, Rafael has just thrown into the chat. Just a sec. Can you hear us?
Yes. I can hear you, Peter.
Ah. Would you like me to share your slides? I can do that, but is it? I guess it's not the sharing screen that's not working. It's the audio.
I could hear him just now.
Oh, okay.
But it was very, very soft.
Okay. Anyway, he's just joined.
Rafael, I can hear you, but your voice is very, very soft.
What about now?
Perfect.
Yeah.
All right, good. Okay, I'll share my screen again. Sorry about this. Where was I going? Did you hear me talking about this?
Yes. Yeah, we heard you talking about HTLCs.
Okay, I think we can move back if there's some doubts. Right. After that, we have blockchain of blockchains. So the frameworks that provide usable data, network consensus, and that and have inbuilt interoperability features. Okay. And taking the example of Polkadot is essentially a blockchain that's composed of parachains, and parachains can be visualized as mini blockchains, mini chains with their own functionality. They can have their own consensus rules. At least in Cosmos, I think it's a bit more flexible than in Polkadot. In Polkadot, you have these shared security, shared consensus, and those are tied to the relay chain, which is some sort of main chain. Okay, and this relay chain is synchronizing the process of accepting transactions from accepting blocks of transactions from each parachain and thus constituting a global view on a global state of the system. Okay, these you see the difference between these and relays is that relays are normally done as artifacts to connect heterogeneous blockchains, and these we can perceive these relays as connecting homogeneous blockchains. So each parachain, although they're built with substrate and they can be very different in practice, they belong to the same infrastructure, let's say. And then each parachain can communicate to the outer world via bridges that are provided via the relay chain. Okay, so you have the parachains that are the application-specific blockchains. You can see on the left, the collators are building the blocks of transactions, and they send them to validators that on its turn add them to the relay chain. And this is built with substrate library that defines well, all the functions, methods, runtime that you need to develop your own parachain. And also you have, this ecosystem is very much based on game theory, where the authors try to perceive what's the best reward punishment mechanism for these to operate. Okay, related to hybrid connectors, blockchains are somewhat related to hybrid connectors, but those deserve their own category because they're trying to solve the specific problem of connecting private and public blockchains. And we have some work here. So for example, Hyperledger Cactus, I'm going to talk a bit about it. The Open Digital Asset Protocol, so it's blockchain agnostic protocol. Hyper Service, and some recent work, Hermes, which is some fault-tolerant middleware for blockchain interoperability. It essentially instantiates the ODAP, Open Digital Asset Protocol. Hyperledger Cactus is the latest Hyperledger project, fully dedicated to interoperability. So, and by the way, for the ones who don't know, Hyperledger is an organization that is dedicated to provide tools for enterprise blockchain. Right? So they have a set of blockchain projects like Hyperledger Fabric, Hyperledger Bezu, Hyperledger Sawtooth, and then tools for testing such as Hyperledger Caliper. They also have blockchains for self-sovereign identity, Indy, and Aries, which is an agent. There are really lots of projects. And this project is very nicely placed because, excuse me, because it can be the connecting glue, let's say, between those projects. The idea is that Cactus can provide the end user access to several ledgers at the same time while standardizing the process of connecting to those. So the user can be normal end user, let's say. So I could want to connect to several exchanges or to several blockchains on my own behalf, and I could use Cactus to implement my own trading bot, to implement my own logic of accessing those ledgers, any use case I want. We rely on a plugin architecture. So currently the project is divided into modules. So for example, Hyperledger Fabric connector, Hyperledger Bezu connector, and Bezu is a smart client for Ethereum, by the way. If the plugin exists, we can just use the plugin. Otherwise, we can code it, right? We can implement a plugin interface, which is standardized, that aims to provide some standardization across plugins, making this approach scalable and more user-friendly and developer-friendly mainly. So it uses a plugin architecture. It wants to be secure, like, and this is a huge catch because I don't think cross-chain security across public and private ledger has been extensively studied. So this is one of our goals, to study this research area in particular, and also low impact deployment, for example. So most plugins are relying on Docker images, so it's quite easy for you to deploy your own Fabric test ledger or your Bezu test ledger and see the interactions between those ledgers. So it's also very good infrastructure to perform some research. And this is a high-level overview. It's probably a bit outdated, but the general idea is here. As an end user, you have a UI, and then you have a Cactus client, and it's an SDK. And the way we've done it, each plugin generates an SDK in your language of preference. So you can use this SDK to access to a Cactus node, which is actually, we can perceive it as a blockchain node because they can happen to talk to other Cactus nodes and implement cross-chain logic as a group, right? Using the consortium plugin. And then you can have interesting conditions like, okay, you're connected only to Fabric, I'm connected to Ethereum. If it happens something there, then I'll do something on the blockchain I'm connected to, right? And this presupposes that we can share state across blockchains, and in particular across private blockchains, which is a very hot research area nowadays. BL plugins are business logic plugins, so it's the logic you want to incorporate in your use case. Validators are essentially components that are retrieving information from the blockchain, and connectors are components that are actively performing operations on blockchains. So combination between validators and connectors is what constitutes the bridge to the blockchains that exist. Regarding standards, just a very quick overview, we have lots of emerging standards being deployed for not only blockchain, but interoperability in specific. And we also are seeing the rise of supporting technologies. So for example, decentralized identifiers and verifiable credentials that allow identity portability, which is highly desirable for blockchain interoperability in general. So for example, if you want to migrate a blockchain solution, identity portability, it's quite useful. And also cross-chain programming languages, for example, Tamil, by the, how they're called, Digital Asset, I think that's the company's name. And also the hyper-service language, with a more academic project, but tries to solve a similar problem. Also, a supporting technology or effort that I would like to emphasize a bit is the blockchain view. I'm working on this currently. A view, it's an abstraction of the state of a particular blockchain in a particular time moment. So we can perceive it as the snapshot of a blockchain. The applications are quite interesting. So if you have, and this, by the way, it's a survey on view integration. It's on the business process research area, but we try to make a bridge with blockchain. That's our foundation. And the interesting thing about the views is that you can it can help you greatly with migrations. It can help you greatly with audits, and it can help you understanding what's precisely happening in a blockchain. Can be a great tool for exploring what's happening. So the idea of the views is that, you know, you have a view generator, it collects the transactions and the blocks of a blockchain, and it constructs a state, which is an abstraction of that information. Okay, and then you build the view. Okay, so the view, it's the snapshot with some more things, and you build one view for each stakeholder, for each participant on the ledger. We're talking specifically, okay, about private blockchains. This is where the views would be the most interesting, because you have different views on private blockchains. If you have, for example, private data collections, where a subset of the stakeholders can access a subset of the ledger. Okay, and then once you have views, you can merge views actually and build a general view, an integrated view of that ledger, and this is what you use for migrations. You can also perform computation on that view as long as you keep the proofs of such computation. One more thing that I find interesting and perhaps worth exploring is creating views of a stakeholder from different blockchain he's participating at or she's participating at, and then merging them, providing our participatory overview on several ledgers. So these would be helpful in visualization. So some interesting topics, interoperability, in my opinion, of course, between public and private blockchains, which is which needs some effort. Blockchain migrations, decentralized identity, standards, and the blockchain of blockchains approach. And all of these could be also combined with public connectors. So blockchain interoperability is a research area that is currently expanding, and we can perceive some practical applications from it. In particular, enabling an internet of value for blockchains. So as in the beginning, we had lots of local networks, and when they were connected, it created the internet and it unlocked much more value. With blockchains, it could be something similar. You have lots of isolated blockchains, and when you combine them, it will generate more value. Blockchain interoperability can reduce risks, okay, increasing the probability of governments and organizations to invest on blockchain. And I believe interoperability is one of the drivers for blockchain adoption as an underlying technology. Regarding future talks, we have Daniel speaking on the 12th of May, and then Peter talking a bit about Ethereum rollups and sidechains. There's also a supply chain blockchain conference that has a free registration, so feel free to register and to participate. Yeah, and this concludes my talk. Thank you very much to be present. Sorry about the little technical problems, and I'll be happy to answer any questions.
Ollie, everyone's rushing in at once to ask a question, aren't they? What do you think the biggest challenge of blockchain interoperability is?
Oh, that's a hard one. Yeah, that's a hard one. There are lots of challenges. In my opinion, you see, blockchain has. We essentially have two views, high-level views on the usage of blockchain. We have public blockchains, where I think the philosophy is for building a decentralized infrastructure that the whole community can use and self-manages somehow. And we have private blockchains that are used for companies to increase efficiency of their processes. So when it comes to connect them, it's surely difficult because they have different philosophies and different ways of operating. So the standards play a big role, right? It's like HTTP. When everyone agreed on it, then everything came from it. You could really start using the internet in a very solid way, which HTTP, which is a standard. And for blockchain interoperability, I believe you need something similar. You need standards to tell exactly how blockchains should communicate. The problem is that there is no standard, at least there is no universally adopted standard. That would always be the case, I suppose. You'll have different standards, but as you have two very different communities of people or of users using blockchains, in particular public and private, I believe it could be a challenge to find a proper standard that, at least it requires a lot of work, a proper standard that can take the best of both worlds and reach an agreement between them. So for example, in private blockchains, if you're interested in asset transfers, you need to, well, you need to know the customer, you need to collect information about the person transferring an asset as for regulations and legislation. And people from transacting in public blockchains might not be eager to provide such information. So there is, let's say, probably a clash between ideas in the field, and that could be one of the challenges to understand where's the sweet spot, where the standards should be going towards.
Yeah, David Hardridge has put a question into the chat. I don't know, David, do you want to run with that, or should I read it out?
Yeah, it's essentially, can you get real interoperability agreement between different blockchain systems when you've got different consensus mechanisms? Some are probabilistic, some are deterministic, and then some have forks, and because some are so fast, they allow more for transactions essentially to be reversed when they don't go on one sort of particular chain.
That's a very good question. I think it tackles one of the interoperability's main challenges. I think yes and no. So people seem to forget about forks often, but if a fork occurs, you're basically screwed. You have nothing. The underlying assumptions that you need for interoperability are not very well defined, except in some papers that are cryptography directed papers. So universal composability framework kind of papers. But I think that generally this is still trying to be agreed upon. And one of the assumptions that we think it should stand, at least in Cactus, when we're designing the system, is that we should assume that the underlying blockchains are secure. So they're not forking, they're not being attacked and double spending attacks occurring. Because if that happens, it would be extremely difficult, if not impossible, to guarantee correctness and safety on the interchain processes, right? So you need that basis. Yes.
But then wouldn't, I mean, for Bitcoin, you've got longest chain, and say Ethereum, you've got heaviest chain. So they're probabilistic finality. So they're not forking due to, say, someone doing a 30% attack. They're forking due to, just due to how they operate, due to the latency across the globe. And that sort of
I was talking about hard forks, permanent forks. Those temporary forks are, let's say, normal, and they can be handled. So one of the ways for you to do that is I'll only conduct a cross-chain operation when on the Bitcoin network. How many blocks are they? 6, I think. Only after 6 blocks are confirmed. So we are actually accounting for the possibility that we are exploring a fork that will be exploring a block that will not be included on the longest chain. So we only consider it settled after this period of time. This for probabilistic blockchains. For non-probabilistic blockchains that run, for example, Byzantine fault-tolerant based consensus, then we can consider them final, assuming that the nodes that are producing the blocks and the transactions are honest and are not changing them afterwards. So I think this is the way of coping with heterogeneity. It's giving a safe space, a safe buffer between for transaction settlement. And I think this could accommodate different consensus mechanisms.
Are there any other questions?
I guess I might have a question in terms of rather than just research stuff, which ones are actually seen in the wild, like in use? Like I presume the cross-chain time lock, there are actual contracts out there that do that.
Mm-hmm.
What other sort of options do you have right now that is actually not just a standard that's in a design or a spec, but actually implemented like somewhere?
Yeah. Fair point. We have lots of stuff on the public connectors category. So you have sidechains in production. You have the hash time, lots of hash time lock contracts in production being used. And I think one of the very popular use cases is transfers, cross-chain asset transfers. For example, the cross-claim tries to do that between blockchains, and I think they were able, and that's in production. They're developing a Polkadot bridge right now. Besides from those, there are some enterprise solutions that in the blockchain of blockchains, it's more or less also deployed. So with Polkadot and Cosmos, they're maturing quite quickly. Polkadot is launched, I believe, Cosmos too. But hybrid connectors are not so matured at the moment. So you have some enterprise solutions like for example, Quant, that takes the gateway-based approach. But then, for example, Cactus does not still have a version 1 released, only pre-releases. And most blockchain agnostic protocols do not have an implementation, or it's not validated in the industry. So there's still some way to go until we have robust tools that we can use. Although Cactus is predicted to launch, I believe, after the summer or something like that. And if Cactus is deployed, then I think that enterprise interest in the area will rise and will speed up things a bit. But I think we're probably still 1 year or two before we have something robust in the space of hybrid connectors, let's say.
I've got a question. So with Polkadot, I mean, you've got shared consensus across the various parachains. And I always thought of that as not a multi-blockchain system, despite what the marketing says, and thought of it more as a cross-shard system, where essentially each of the parachains, because the original envision was that each of the parachains could be heterogeneous, so they could be different. But I think what they've actually deployed is every parachain must be the same technology. So I don't know, is it really a cross-shard system, or do you think there are merits for why you would classify it as a cross-blockchain system?
Yeah, that's a very fair point. That was actually one of the critiques I was raising in the survey regarding blockchain approaches, because they're promoting, let's say, interoperation between homogeneous systems. So you could consider it a cross-sharding transaction if we're using information from across parachains. Exactly. I believe that the typical sharded blockchains do not have different functionality across shards. I'm not an expert on this, but I believe that's the case. But in Polkadot, you can have different smart contracts on each of the shards. And I think that's a distinction that probably deserves its own category, because that's the first step at building blockchain of blockchains, especially if we link each of these shards or parachains to external blockchains. So you would have logic from not only your parachain, but also other blockchains, at least information, data, right? I believe that's the main distinction.
Okay, thank you.
You're
Are
welcome.
there any other questions? All right. Well, look, thank you very much for giving your talk, and I'm going to put it straight up on YouTube. I'm not going to edit out the 20 seconds, because at the end of the day, if I muck around, start editing videos, then it'll be weeks before they ever get up on YouTube. So we're much better off just to launch them raw. So anyway, so thank you very much for your talk and your time. I really appreciate you taking the time to do this, and let's all do a bit of a virtual clap. Yeah.
Yeah. If someone
My
can work
pleasure.
out how to press the fast forward, then that's their problem for the gap.
My
Very,
pleasure.
very
Thank
true.
you everyone for listening.
It was
and
excellent talk. Thank you.
asking. Thank you very much. Appreciate it.
All right. Bye-bye.
All right. See you next time. Cheers.
Bye. See you.
Bye.